Hi there. Good morning, good afternoon. My name is Lambros Yurdas, and I'm accompanied by Artem and Hubert. And we are here to let you know what we have been doing for the last few months on our pilot in decentralization of additive manufacturing production. So a little bit about our bios. As you can see, all three of us are maybe if we merge all of our powers, we extend 30 plus years of experience in additive manufacturing. But what I would like to talk to you about is first, who is Baker Hughes? So Baker Hughes is an energy technology company. We are actually delivering engineering solutions in various engineering fields. And we do think that additive manufacturing is one of the key technologies to streamline our production solutions. For this reason, we have created a global AM footprint across various continents, as you can see. And we have produced thousands of 3D printed parts, from power nozzles to manifolds, from jigs and fixtures to sensors. So we really like to evolve on this, but we do have some challenges that we need to overcome. And these challenges are listed in here. So plenty of challenges around our customers, around our optimization of production, around our enable of data modeling. But the purpose of this presentation is all about decentralization of our AM production, because that's also a field that we need to grow. So how do we think that decentralization shall happen, right? We have an end user who is requesting us a component, and we do really need a digital network that is going to connect the end user, the OEM, us, and then suppliers that they are going to be handling production, AM production, on behalf of us, right? So we will then create certified and qualified digital catalogs, and also we need to certify our suppliers. So on this sort of process and on this journey, we need to think about the product and also the process qualification, right? So we will have a product certified portfolio that will be enabled through our suppliers. So the digital connectivity between the supplier, the OEM, and end user is going to drive the cost down and also improve our quality. So for this reason, we came to initiate the pilot of the decentralization project. So we have taken an example of one of the regions that they are of interest to us, and there are plenty more in the future. But we started with the Kingdom of Saudi Arabia. And the business objective was to de-risk single sourcing and also to grow additive locally, right? So the scope of this pilot is to produce and qualify products on another continent, so it's a cross-continent project, and also ensure the customers that they are going to have the quality that we would have been delivering from a different continent. So we wouldn't have done that without our specialized teams, and very many big thank you to our teams. But also we wouldn't have done that with our partners, Octon and NAMI, that they are here to share their experience with us. Thank you.
All right, thank you very Lampros for the introduction. So we from Octon have different solutions that support our customers from engineering to manufacturing to qualification at every step of the process, and we do that in a cost-effective way. So in the scope of this pilot, the goal was to connect customers with OEMs and a supplier to allow decentralized, so localized manufacturing in a way that they can have confidence in the products that are shipped out at the end. The setup is actually pretty straightforward. You have an end customer who raises a demand, the OEM qualifies the products, and then outsources it to the supplier. The challenge here is that in additive, often you do not have enough confidence in the supplier providing you the part at spec, as you as an OEM are ultimately liable for the products that you ship. So what we enable here is that the OEM, through its customer order, which is linked to the production order, and the nest, has access to the build monitoring data in real time. So they can monitor every layer of the print and be informed about anomalies that occur during this process. On the other hand, the supplier, who is actually executing the manufacturing, is made aware of any potential anomalies that arose, can either counteract or make any other actions that are reasonable on that. Then everything is then supplied to the OEM, the report, the parts, and so forth, and then assembled and the demand ultimately fulfilled. So if we look at that in the actual application, how does that run? So as a monitoring engineer from NAMI, you have a dashboard that shows you every pre- and post-recoater layer, potentially with anomaly overlay if you have anomalies. So you can turn those on, you can turn those off. You can go through the individual layers that have already occurred during the printing process. As we can see here, this is the third time we executed the print. We do not really have anomalies on this case, but you always do get alerts should they occur. There's critical ones and there's moderate ones. And then it takes you to that specific layer, shows you the anomaly, and you can assess what course of action you do want to take in the end. So that's from the supplier, so the manufacturer point of view. At the end, of course, you can then create a report that is configurable, so tailored to what you want to expose or what the customer wants. But as the customer, during the manufacturing process, I also have access to this data in real time. So I can see my customer order that has my line items that relate to the production order. And that link is established when the manufacturing is executed. And you can use that to then get to the report and then go through the information that is relevant for you as the OEM, who will then acquire the part through the supplier. And after everything has finished and you would want to do some root cause analysis, you can go into tools for inspection to dive even deeper. And with that, I'm going to hand over to Artem, who can introduce it from the supplier side.
Thank you. So for this pilot project, we've chosen NAMI. Who is NAMI? So NAMI is a Saudi Arabian additive manufacturing and innovation company, which was created as a joint venture between Dusur and 3D Systems to be a key supplier in Saudi Arabia for all additive manufacturing parts. So as NAMI, we are already qualified by all key processes, including DNV certification for oil and gas manufacturing. So also in NAMI, we have all range of technologies, including polymer and metal technologies, and a wide range of materials. So as NAMI, first we received a request, which is a RFQ form from Baker Hughes to produce part. So in this case, this anti-locker mechanism, and then let's say based on this RFQ, we analyzed the parts, we prepared, let's say, the workflow, and let's say based on steps and specification, which needs to be done for this part manufacturing and post-processing, we created our proposal in the system and submitted this proposal back to Baker Hughes. So potentially, that also can be done with multiple suppliers. So OEM can send it to multiple suppliers and get multiple proposals. Depends, let's say, which region they're targeting or like which manufacturing technology. So in this case, Baker Hughes received the quotation and approved the quotation, and basically the system also generated automatically PO for us to start the process and created this order in Octon MOS. So then we went to actually printing step. So for this we used file prep in Octon 3D Expert software to lay out the job and do the slicing. And also we used then 3D Systems DMP Flex 350 dual machine for actual print job. So in terms of schedule and routing, basically that's only not only visible for us internally at NAMI, but also it's visible for customer. And it's really important for customer to see like where is project now in terms of schedule, which step of manufacturing, of post-processing or quality control is passing. So that's giving really full picture to see where is the project now. And of course, let's say this monitoring software, which Hubert was showing, it was really eye-opener for us because this live monitoring really helped us to make job successful because during some first layers, we got actually alert that there is some short feed on the edge of platform where we have one of tensile bars. And we were able to fix it immediately to increase some feed rate on this job. So this actually can help us to make this job conforming in the end.
Right. Thank you, Artem. So I think that what we would like to highlight here, and I think that this slide summarizes all the benefits that we have found out through the pilot project. So if I will start from the learnings, we really realized that the entire industry of energy, but also other industries, would need a common data model. So we need the connectivity in place to ensure that communication is effective between all parties. Thereafter, we need to also think that if we would like to become confident about our suppliers, we need to become also confident about their supply chain. So we are planning and we are in progress of qualifying also the suppliers of NAMI that they are helping for the milling purposes, so all the activities that they need to happen outside the NAMI, but also NAMI in a few weeks. But at the same time, I would like to say congrats for the Octon team that has provided us with a digital network that has become a very, very good tool for us, an enabler in a sense that otherwise this sort of communication wouldn't have been possible. But I will pass to Hubert to talk more about the digital network.
Does it work? Okay. So from our end, it has been a pleasure to have a partner to work with on this, because one thing is like thinking about all of these things in theory, and something else is to truly execute on it. So you will end up with a platform or an application, a solution that doesn't only work, but is driven by a partner who delivers innovative solutions in that space. And that means you will also end up with something that will drive compliance, but it's also cost effective and affordable, because if it works, but it just is not affordable, then you cannot implement it in these kind of environments. It also allowed us to fine-tune the platform to what OEMs are looking for, so that suppliers can adjust to it, can adhere to it, and therefore have a framework of being able to become suppliers for OEMs in these kind of verticals. And now for you, Artem.
Yeah, from our point of view, from manufacturer point of view, it was also great experience working with both teams on this pilot project, and we see like this project really scalable in the future, like to multiple end users, multiple OEMs, and definitely for us to get all the correct data from the customer during process, it's really important. It's not like just you're getting model and drawing, let's say, in spec, and that's it, but really it was very close cooperation on every step on defining actually road for part manufacturing and post-processing and quality control. And we defined basically this road and this traveler, as you want, together with the customer. And definitely this monitoring solution, that was also game changer, and now we also using it internally to monitor just even our, let's say, some trial jobs to get, let's say, alerts if there is any potential anomalies in a build job. And yeah, you actually can see, let's say, that Baker Hughes done some calculation that's using actually monitoring, it can reduce cost of scrap over the year by around 18%, and to save more than 100 hours of print time, just because like reducing number of non-conforming jobs.
If I can complement the comments around the online monitoring, I think it's true that we are building confidence with our suppliers through this online monitoring system that is enabled by Octon. And we have tried that already in our ecosystem, internal in-house manufacturing, and it has shown us benefits. But right now, these benefits are exponentially grown because our suppliers would be able to be equipped with all these components and all these systems that we have already trialed and we have already evaluated. So next steps from now on is to complete the qualification process that we have started with NAMI, and then audit NAMI for both process and also products, and then scale that localization project within the Kingdom of Saudi Arabia with more materials and more products. Thank you very much for the attendance, and we are going to be really happy to answer any questions later on. Thank you.
Thank you very much. Any questions? We have time for maybe one question before our quick break here. Yes, sir.
Thank you. I'm just keen to know, how have you planned to put in your requirements as the OEM through the system? So rather than the standard paperwork-based stuff on the drawing, have you looked at setting specific process requirements, which then the system is automatically picking up? So no pauses allowed in the build, for example, or any of those specific requirements? Have you driven those through Octon?
Correct. All of our requirements are actually transferred to the NAMI tenant from us, and we have already set material specification documents, all the designs, all the manufacturing routers, because this component that we have piloted, we have already manufactured that in-house, so we knew all the steps that we will have to take to actually deliver the product. So that sort of communication was enabled through the platform.
Yeah,
Yes,
and to add to that, it's not only the product specifications that are captured, it's also the conversation in relationship to one order for the line items that are requested. Meaning there's a module in there that allows you to communicate with the customer. It allows you to communicate internally in a separate thread. And you can also use annotations on 3D models to effectively communicate as well if there's any clarifications that you can use.
Okay, and where else can we find further information from you guys?
Yeah, please feel free to visit us in the same hall. We have 3D System booth and Octon booth. So welcome, and we will share more information with you if required.
Perfect. Gents, thank you very much.
Thank you.
Right, we have